Which is, by the way, like you said this very casually, but it's actually insane. Today we're joined by Mehdi, who is the CEO and co-founder of Veris AI. I think, Mehdi, you were one of the first people I ever met who mentioned anything about an RL gym, and now they're like all the rage. And so I'm super excited to have you on the show to talk a little bit more about Veris, what you guys do, and how you guys were kind of honestly the first commit to this RL gym concept. So I'd love to start with just, do you want to do a 2 second, really quick blitz intro of what Veris does?
Yeah, for sure. Veris is it's a sandbox environment where we allow agents to learn by experiments. We believe building agents have to be experimental, have to be something that the agent should be learning by doing. And in order for them to have that kind of experience, instead of doing that in production, we can do that in a simulated environment. And that's what Veris does. We build environments for agents for training.
Amazing. And I'm so excited to dig into like every single part of that. And then to start off, I would love to hear a little bit more about your founding story. How did you meet your co-founder? How did you guys even decide to work on this?
Yeah, I've been thinking about starting something in the agentic space for a while, and I've been experimenting with different ideas and sort of working on with different companies and different startups. Particularly, Andy and I were part of the same sort of community of founders. And at that point, we were working on different ideas, both in agentic space, but mostly on sort of separate ideas. When we were like in touch, we were talking about different problems that we had. And I was prototyping some ideas around simulation at that point, and I was like getting feedback from Andy and talking to him about it. And at some point, we both realized that this is actually a much bigger problem than the things that we were working on, because has like much wider sort of application and sort of allow everyone, a lot of companies, a lot of enterprises to actually build reliable agents. So we started to work on this together.
That's amazing. And I'm actually curious, everyone is talking about RL gyms right now. What, in your words, is an RL gym?
Yeah, for sure. Yeah, auto gym is in the book now. So RL gym is what we would call like a subset of environments for training agents. Specifically, what you can do in an RL environment is to give reinforcement learning signal back to the agent, which is usually in the form of thumbs up, thumbs down, or like maybe a scalar data as a feedback for the agent. And these are particularly very powerful for things that you can verify easily, right? So for example, if you have a code, you're writing a code using a model, you know whether that code is correct or not by maybe passing a test or compiling. So those are signals that you can verify. And based on that, you can give feedback to the agent or to the model, whether that was good or not. And that's basically running that multiple times and many under many epochs, you can train an agent to be really good at particular set of tasks. So it started really with coding and math because those are very easy to verify. This is part of like a bigger kind of umbrella of environments that overall we believe are important for training agents as like a general purpose kind of feedback loop for the agent. And you can use these kind of feedbacks in many different ways, like RL, or you can use it to train agent using better prompts, for example, right? So you can basically craft better prompts from the feedback that the agent receives from the environment. Or you can use the data that you generate in this environment to fine-tune a model, like just supervised fine-tuning, basic methods. So there are multiple ways of optimization. RL is one of them. And RL gyms particularly are the kind of environment that gives reinforcement learning signal back to the agent.
Yep. Yeah. And I guess like one question I have for you is it who is this useful for, and like what types of agents? Because is it useful for an agent that is more simplistic? Like some of the examples that you gave were a little bit more complicated. So I have a coding environment. I have tools that I may be using as a developer AI agent. Maybe it's a browser use type of agent. Those make a lot of sense to me because there's a lot of state that's stored in that environment. But like if I'm just a I don't know, lane graph, state machine type of DAG type of AI agent. Is that still useful? What are the types of use cases you've been seeing?
Yeah, what we see is that depends on the complexity of the agent. Like the coding agents are also very, very complex, right? So based on the number of things that they have to look up and the number of tools that they have access to can become very, very complex. So I think that the difficulty here, or the maybe the difference here, is that how verifiable the outcome is. In many, many cases, in enterprise use cases, the end result, and sort of if you give a trajectory of an agent to an expert, and you give it to two experts, they necessarily not agree on the specific value that you assign to them, or a specific score that you assign to them. Those are more complex, so those are more difficult to create a reinforcement learning environment for, because if it's not completely verifiable, it's hard to know what kind of signal to give back to the agent. So that's why the kind of use cases that we see is across the board, because we are not just focusing on reinforcement learning, right? So because we have like different optimization based on the need of the agent, we can give it different kind of feedback. We can make the prompt better, or we can just use, for example, supervised fine tuning to make the agent more like funnier or more formal or whatever, like those kind of like intangible qualities that oftentimes is needed in enterprise applications. We can also tune those kind of behaviors of the agents. But the use cases that we see across the board is a lot of back office automation type use cases these are workflows, or a combination of agentic systems plus workflows. We see a lot of traction in supply chain type applications, where you have like many different tools and you have to communicate with different stakeholders, and it's a good opportunity for agentic systems to automate a lot of that. And also in fintech and financial services, we see a lot of adoption as well, because again, the problem there is that there's a lot of regulation, and the agent have to follow all those regulations, and sometimes those regulations are not completely verifiable, right? So they are like subject to interpretation, and having a way of teaching the agent even in those kind of situations is not necessarily only RL that's needed there. It's a combination of RL and other techniques.
Yep. Yeah. I mean, I think what is so interesting about this is that I don't know if you remember, like maybe 5, 10 years ago, it was really hot to have this concept of a digital twin. And like this is actually a digital twin, but it's like on steroids, because it's like, let us replicate, every single system you have, and then have the agent run through it in every single possible scenario, go down these different paths, and then you return the one that, returns the fastest, has the fewest number of steps, is the most efficient, is the most accurate. But I'd love to, maybe just dig down into, dig a little bit deeper into the things that you mentioned that compose an RL gym. So the environment, the trajectory, the evals. Like maybe we can just walk through those one by one, and like on the environment side, I'm kind of curious, like how rich are these types of environments? And then how do you manage the like forking, branching when the agent is making different decisions? That's maybe the first question. Then we can go to trajectories and evals.
Yeah, for sure. So as you mentioned, exactly. So we have this environment that creates sort of some sort of feedback to the agent. Then there's like trajectories that you get from this environment, and there's evaluation phase, and then there's optimization phase, right? So these are basically the primary components. On the environment itself, as you exactly mentioned, like it's a digital twin of your production environment, and that includes basically three components. So one is all the tools that this agent is communicating with, right? So in the sort of software engineering paradigm, you had development, you have a staging environment, and you have production environment, right? And in these environments, if you wanted to do end-to-end integration testing, you had to basically create a copy of your whole system in each of these environments. This is kind of in parallel to that, except here we are not, for example, if the agent is communicating with the Salesforce instance, we are not actually having a Salesforce instance there. Instead, we have an agent or a stop agent that acts like a Salesforce and give feedback to the agent. So mm, having mock tools or simulated tools is one component of this environment. Then you have users that communicate with this agent via chat or email or voice or whatever that is. So you have to simulate those users too, um, in this environment. And then you have a bunch of scenarios, right? So the scenarios describe the kind of end-to-end story that you want this agent to walk through and sort of experience. And this comes from, if you already have something in production, comes from the logs of the production. Oh, so what are the kind of conversations that the users have with this agent, for example, or what are the kind of tasks that the agent wants, that the user wants this agent to do? So you get the scenarios from that. So these different components, users, tools, and scenarios, create a simulation environment where the agent can interact with and have very similar experience to its final production environment. So that's kind of our environment, basically.
Yep. Which is, by the way, like you said this very casually, but it's actually insane. It's like I could probably through some differential privacy thing even like replicate exact, log patterns from, my production environment into something else. I can use the LLM to simulate an entire human, pretend to be a customer or persona or someone else within the organization. Like you're saying this very simply, but it's actually really, really cool. Like we basically have created a replica of the organization and like many different scenarios. Okay.
Yeah. So and it's pretty complex too, right? So I'm, as I say, I would like this is very high level, but just mentioning one of the complexities. If you want to use an LLM to simulate a user, that's actually a very non-trivial problem because LLMs designed to be helpful and be cooperative, whereas a lot of users are not. So actually making LLMs behave like a human in those conversations is quite challenging and needs a lot of specific model building and fine tuning of models to build it in that way. So there's a exactly like angry customers will have its own goal. Oftentimes, you and I know that you can easily change the goal of the LLM easily by just convincing it because they want to be helpful to you, but not humans. So there's a lot of those nuances that you have to work through.
Yeah, I mean, we saw a couple companies recently, and I think they started with the let me automate like research or user research interviews, and then they started there, and then now there are like companies that are simulating entire humans, trying to do research panels and large scale surveys with these synthetic humans. Some of it seems like very sophisticated prompting. Some of it is like I will literally ask real humans, 100 questions or 200 questions about their lives and then have that ingested into maybe a smaller model. So there's a lot. I mean, there's a lot there
So
that's really
all
interesting.
kind of space. Yes, exactly.
Yes. I
Yeah.
mean, philosophically speaking, it's kind of like the humans are in there somewhere
Yes.
because it was trained on all of the internet, but
Right.
you have to get it to behave coherently within that
Exactly.
scenario.
Yeah. And I would say for us, we are the problem that we are tackling is like a subset of the problem that those companies tackling, right? So we are working with domain specific set of agents that are not by design talk to the entire population of the United States, for example. So it's like usually like a subset of like very specific type of users that would interact with these agents. So that's why our problem is much more contained, and we have like tools to actually make that very high fidelity and very good.
And then on the forking side, like how many paths are we talking about? Like how many paths is the agent feasibly going down?
Exactly. That's sort of the crux of the reason that just standard eval doesn't work with agents, right? So there's infinite, like, or very high dimension forking happening inside these trajectories. So the nice thing here is that we built Veris from first principle to be maximally parallelizable. So you can give the same scenario to hundreds of different copies of the agent and have a slight variation of the same basically concept for the trajectory, and create different nuanced trajectories based on the same scenario. And that's kind of like by design, it's built in a way that you can give it, for example, you have a user who wants to ask questions about their bank account and subscriptions. So that's like, let's say that's the scenario. Then from that seed, that scenario as a seed, you can generate thousands of different trajectories when you give it to when you give it to copies of the agent and the environment to basically roll out. And that creates basically the variation that you need as like a basic exploration phase of the reinforcement learning or other optimization. You need a level of exploration so that you have the kind of data that you need to train the model on later on. So that's kind of our approach, like maximal parameterization.
Yep. Yeah. I think what's interesting is I was thinking a little bit about this. Like, this actually is the successor to the data labeling or the RLHF businesses that happened in the previous generation. So, Scale AI, Surge, Invisible, like, they made tons and tons of money out of just this human annotated data. How does that shift into this RL Gym world? Like, what composition is still useful to have human demonstration versus synthetic? Is there still human labeling that happens on top of the actions that the agent is doing? Or is it just like, here you go, like, here's environment, go play, and like, we'll rate you based on, you completed the task or not?
Yeah, that's a very good question. I think I would distinguish a little bit between general purpose agent training and task specific agent training. I think they have quite different use requirements. For task specific one, I would say a lot of data can be generated synthetically, uh, much more than those general purpose ones. And the specific reason here is that the builder of or developer of this agent, the PM and the developers have a lot of understanding of the type of request that this agent is going to receive. And that can be the seed to generate a ton of different scenarios that the agent may encounter in the wild. Having said that, there is always space for expert data on two ends. One is very edge case type of scenarios that you may have missed. And this is the type of agent that is super risky and you can put it in production and get data in the production. So there's still like some room for human experts to come in and make sure that you are covering a lot of different edge cases that this agent may encounter. So that's one part. The other part is less about annotation, more about aligning a LLM as a judge to human preferences. I think for some tasks, for a lot of tasks, this is not that complex, right? So verification, it's been known that overall, it's easier to verify the task, the completion of the task than actually doing the task. So LLMs are pretty good at understanding whether a task was done and whether a specific set of criteria has met or not, have met or not. However, there are nuances there that, like, if the requirement is very specific, if the metrics are very nuanced, you may want to bring human experts to tune that LLM as a judge, making sure that the scores that's giving is aligned with the human preferences. So those are the two pieces that I would say still like there are some need for human experts, but again, for task specific agent, this is much, much less than those like general purpose agents.
Interesting. And then in the market as a whole, are you seeing more pull toward the general, training for general purpose or for the task specific? And maybe it differs actually depending on whether or not you're selling to the foundation model labs or to enterprises.
Exactly. So labs are pushing for general purpose agents. Obviously, they want to build like a type of agent that can do a lot of different tasks, whereas enterprises and companies who are building these like task specific agents are more interested in those kind of data. So that's why we are, for the most part, are working with startups, growth stage startups, and enterprises who want to build their own task specific agents.
Okay, interesting. Cool. I'd love to shift a little bit to trajectories. What type of data can you actually collect? Is it like click streams, actions, decision points? And then for like, especially long running tasks where it's like, I may not know if it's successful until 100 steps into the future. How are you managing that? And what kind of data is actually useful in maybe the question is more about like sparse versus dense rewards. What are the types of signals you can get? How much fidelity is actually useful?
Yeah, that's a very interesting sort of also aspect of RL versus other optimization methods too. So yeah, these trajectories are basically a set of many different turns that the agent have to make, like a lot of tool calls, a lot of conversation back and forth with the user. Um, Most of the agents that we work with do not have a computer use type interactions. So there's no click around kind of components to it. It's mostly MCP APIs, these kind of interactions, and then some sort of through basically portal to talk to the user, whether that's a chat, WebSocket chat conversation, or email back and forth, something like that. So those are the kind of the components of the trajectory. But exactly, you're right. It can be very, very long. It can be hundreds of turns. So that now the question is, if you have a very long horizon task with many turns, and then you want to just give it one score, and then you want to train based on that one single scalar score, is that an efficient way of training? The answer is no. But you need a ton of data if you want to use just a like basic normal reinforcement learning sort of algorithm to train an agent like that. So that's why we are not using it that way only. Um, what we do is a combination of reflection of these trajectory using other AI models to distill that into specific set of feedback that we can then use specifically for prompting or for other methods, so that we don't focus on one score for the entire thing, but we can basically mix and match different optimization methods to accelerate the agent.
Yep, got it. And then, and like maybe can you give me an order of magnitude for like how it sounds like the tasks are could be up to hundreds of steps. How many examples do you need? How many simulations are you running to get something that's usable?
Yeah, thousands of them. You need on the order of some type, depends on the again that the complexity of the agent is a function of the number of tools that this agent has access to and the number of tasks that it needs to cover. Sort of a kind of like a pretty simple math of the number of scenarios that you want to cover, number of tools that this agent has access to, and the number of persona that you think is going it needs to interact with. So if you sort of multiply those, you can get a sense of the order of magnitude of the number of samples that you need to cover everything, all the scenarios that the agent is going to be interacting with. So yeah, like the scale is high. That's why like prioritization is an important piece of the architecture, because otherwise you can never finish these kind of integrations. But with prioritization, you can basically get a ton of data in a reasonable amount of time.
And then just quickly on the eval side, how do you decide what is good? And then how do you know the agent is on the right track for some of these long horizon tasks?
Yeah, eval is basically a set of rubrics that we work with our clients and our partners to come up with. We help them with some standard ones and the kind of things that we see, other best practices that we see across the board, but they also have very specific needs and specific kind of opinions about what success means for that particular task. Task completion itself is fairly straightforward, whether the agent finished the task or not. You can sort of get that fairly easily, but that's not enough, right? Sometimes you want to know the quality of the execution, how efficient was the agent in executing this task, was the communication with the customer in a specific format, a specific tone that you wanted. So a lot of those kind of nuanced things are built on top of this, and then we use a combination of LLM as a judge and verifiers to basically operationalize those rubrics into a set of scores, and then we use that downstream for optimization.
Amazing. Yeah, it's, and I don't know. I actually do want to shift gears a little bit because I know you guys don't work on computer use agents, but one of the things that was weird to me about computer use agents and the amount of energy and effort that is going into them is that it seems like very almost anachronous for the AI agents to be using the interfaces that were made for humans. Like the GUI was made for a human, and then to your point, it's like it adds in so many layers of complexity because you could click anywhere. You know, you have these click streams, but it's a button. and it just like multiplies almost like the number of tools or variations you could use. I'm curious, like, yeah, how much of work do you think will be automated via this computer use, browser use type of thing versus the MCP API integration that you guys are talking about?
My mental model for distinguishing between the use cases for computer use, browser use type agents, and sort of these kind of automation agents is repeatability of the task. If you have a one-off task that you have to basically fire off, computer use oftentimes makes a lot of sense, right? So you basically give access to your browser and then it does that and for you. But if there's a task that is like repeatable, right? So you always want to have like a workflow for incoming complaints from your users, right? So that's something that you have to do it over and over and over again. For those kind of things, I think browser use and computer use is very brittle and kind of unnecessary too. Now, there is a space for the kind of, as you said, the kind of tools and SaaS tools that are closed and they don't have an API. What we see out there, the way that people work on those and the way that they solve that problem is that they build like a specific actions that they have to, or a specific kind of workflows that they have to do inside that tool. They create a very fine-tuned model specifically for that. And sometimes that's not even a model, it's basically a workflow that based on the DOM you create. And then you wrap that into an MCP. And then you give that MCP to the user, to the agent. That kind of computer browser use, I think, is going to be more applicable for enterprise users than, oh, let me give you access to my computer and then I'm going to watch this agent use my computer to do things. I don't see that as like a pattern that is going to be applicable in enterprise settings anytime. That's the way that I distinguish between the two. Yes.
Yep, got it. So it's like almost like a Playwright or Selenium script, and that's packaged into an MCP server, and that works. But you've been finding that like general purpose computer use is maybe too slow, I think, or too unreliable right
No.
now.
Also, from the security and privacy standpoint, it's a nightmare to contain
Yep.
those kind of agents from not clicking and not seeing the pages that you don't want them to. I think it's a very difficult thing to get to enterprises.
Yep. Yep. Yeah. Okay, here's a controversial one for you. Are AI agents actually working in the wild, and where are they failing, or are there common failure points?
Yeah, the 2025 was supposed to be the year of agents, but when you look at under the hood, you see that you rarely see an actual agent in production, even today. I think we talk to a lot of enterprises who outwards. If you read their PR, you think like there's a million agents running around in their code base and in their back office, but when you actually talk to them, the reality is that that's not the case. So I think where we are with the agentic systems are low-hanging fruits for the most part that do not require a lot of actions that are sensitive. These are basically a version of deep research type agents that, yeah, like bring in a lot of knowledge for the user to read and basically take action, humans take actions. Now, all of these companies will have built those kind of agents. Now they are at the place that they want to go next step and actually take actions on behalf of the user, and they don't have good set of tooling to enable that. That's kind of where we situate ourselves, right? So if you are there, you build like a version of basically low-hanging fruit types of agents, you are providing value to the user, but really the next step is to take actions. That's where usually they come and talk to us and we enable them to get to that point. But yeah, for the most part today, it's very rare to have those kind of agents in production. But we believe by providing a set of tooling like ours, but also there's other aspects of the problem, like for example, the authentication of the HCP and those kind of things that other people are working on. I think a lot of these things have to come together in the next 6 to 12 months. We have to see more and more of these in production.
And then is there like a complex example, or what is the most complicated agent you've actually seen run in the wild?
The most complex thing that we've seen is kind of a version of back office automation that does a lot of meeting planning, a lot of updating of documentation, a lot of communication with HR type toolings for employee onboarding and offboarding and those kind of things. So it's a pretty complex set of tools that this agent has to interact with. So that's maybe the most complex thing that I've seen out there that is actually take actions, right? It does a change that is either irreversible or very difficult to reverse. The other set of examples that we've seen is in supply chain, specifically in sourcing, communication with the supplier, and those kind of things, negotiation. We've seen some examples of that now getting into production, still like not like phased in kind of stage, but those are the maybe the most complex things that I've seen out there.
So coming soon, but
Coming soon.
maybe
Coming soon.
not quite yet. I think the distinction that you're making with like the agent actually taking action, I think is a big one because there's so much trust that you now have to instill in the agent that they're going to do something correctly. They're actually going to act on your behalf. Whereas I feel like the first generation of companies was kind of like, here's a chatbot, and it'll send you a message, but it's not really writing the code, or it's not actually really performing the action. Um, Cool. Okay. One question for you that I had is you mentioned a little bit, but it's like in production, OpenAI now has like thumbs up, thumbs down. And that was like kind of like the first version of this continuous learning type of loop. And when I say continuous learning, I'm thinking when the user interacts with the agent or learns something, it is actually like updating its memory. It's learning like a human employee would. I guess I've heard kind of two reasons why this is not working right now. One is it's just way too slow to do continuous learning in production. And then the second that I've heard is catastrophic, like forgetting is a really big risk. And so those are the two big things that people point to as to why we don't have continuous learning yet. The other argument that I've heard is we actually need a fundamental architecture shift, which is like the transformers are like maybe not going to be able to do this, and we may need to shift to state space models or something else that kind of captures or compresses super long amounts of context into like some sort of latent space type of thing. I'm curious what you think about it. Like, how far are we from this holy grail of continuous learning? What's actually going to get us there? Does it require a fundamental model architecture shift?
Yeah, yeah. Continuous learning is the holy grail of building agents that feel like human, that feel like they are learning on the job. I would make the same distinction that I made before, that there's a difference between general purpose agents and task specific agents. The latter one is more like you're hiring a new employee, and the first few weeks is going to be bumpy, and even if they are super smart and they have PhDs, at the end of the day, you have to teach them the specifics about the context of your company and the way that you want them to do your job. That piece is much more achievable to build today. I think we have some solutions for them. Again, depends on the complexity, depends on the horizon, how the length of the horizon of these tasks. Many caveats there, but for the good class of these type of agents, we have tooling to do that. And a lot of what we are building is basically enabling any enterprise to build that kind of flywheel for themselves. For that general purpose kind of agent, that's much harder problem and much more complex problem, because oftentimes what you learn in one aspect may interfere with other aspects of what you learn. There are research from Berkeley actually that shows, for example, if you teach an agent bad coding, it also impacts other behaviors of the agent. For example, it made the agent a racist agent with a lot of weird other sort of behaviors. These agents that needs to have many different properties it's very hard to keep all of those properties improved at the same time and over time sort of evolve them with the same pace. Whereas for task-specific agents, this requirement is much more relaxed, right? I want to build an agent that's just good at in transaction sort of automation and some specific set of tasks that we want it to do. And we don't care whether it can write good poetry or not. But this is not the case for those general purpose agents. So that's why, like, I would say for passive agent, you're much closer to getting to those flywheels. But for general purpose one, I think we still have things to do, as you said, like maybe new architectures required to enable that kind of continuous learning.
I guess that's true about humans too. It's like every skill that you have typically comes with a trade-off. So it's like a double-edged sword where it's like you can't be like the nicest person in the world and also like simultaneously very aggressive and like a go-getter salesperson or something. So it's always kind of these trade-offs, and it's interesting to know what things are correlated and what things are not.
Exactly. And they are correlated in a way that we don't even know, we don't expect, right? So that like we can't sort of foresee what kind of impact this going to have. And that's kind of the scary part, that you don't know how it's going to shape up.
I think it's interesting also, and I'm curious about your philosophy around this. Or in the early days when people were first building application layer AI, like everyone was training their own model, like and they wanted to like own the model. And then now I see a lot more startups where they're like, nope, like I'm just gonna use a state-of-the-art model, like I'm gonna use Claude or GPT-5 out of the box, because like whatever the new release is going to be, it's always going to be better than what I can build internally, and it's like a waste of resources to invest in the training of a model. But I will build scaffolding, I will build tools, I will build all of that around it. What are you guys seeing, and like what is your personal philosophy around like is everything model and like should you just use the state of the art in building versus investing in everything else?
Yeah, I think the reality is that the speed of improvement in models have been so fast that it's very difficult to justify training your models and keep training them. It just economically doesn't make any sense, and you're always behind in terms of the capabilities of your model if you do that. Having said that, it seems like some of the improvements on the model side is like slowing down a little bit. We didn't see that much of a jump in GPT-5, for example. A lot of
Yeah,
these,
what happened with that? I feel like everyone was like universally disappointed. Like, is there any consensus around why it was so disappointing?
I honestly, I believe it was the expectation management issue. OpenAI hyped up GPT-5 a lot, and it didn't it didn't meet that kind of hype. But it's a good model. It's one of the best. I still use it oftentimes for a lot of difficult reasoning tasks that I have. It's a pretty good model, but not to the degree that they were selling it. So yeah, I think the reality is that it's very difficult to justify continuous training of these open source models if you have like such a rapid evolution of frontier models. But I would say, like, at least in the clients that we see and partners when we talk to, so the evolution is like that. So you start with the best model out there. You start with your GPT-5 or equivalent to start up and make sure that you have the full capabilities. You build your agents around that, and you now have something in production that works and provides value to the user. Except the reality is that both on the economic side and also from the latency point of view, they're not really sustainable. They're not the kind of models that you can see long-term you can use, especially if you want to scale up and basically run this many more times. So that's where once those things are nailed down, your value prop is clear, your tool is pretty clear, your workflow is clear, then they're thinking about, okay, how do we reduce cost? That's where we come in and help them distill the same capabilities that they have in a GPT-5 model into a much smaller open source model. Because for the most part, at least for that kind of feature or that kind of use case, it's pretty locked in, right? So they are kind of happy with the shape of the product, but also the quality of the agent. That's what I see the evolution is going to become. So people start with frontier model, and then after they find product market fit, after they find they can provide value, then they want to switch over to open source models for cost and latency reasons. And we are working with multiple companies exactly at that stage now. So they have a model that they have a agent that works, and now they want to go and build the same thing on open source.
So it's like a more like general use of the state-of-the-art model. It's too expensive. You build a task-specific model that's basically distilling that same task down to something that's more economical. Yep. But I do see like the foundation model companies are making really big moves into the application layer. So with Anthropic's launch of Claude Code, or even Codex on the OpenAI side, OpenAI has brought in, the former Instacart CEO and a ton of application layer folks to build out this apps team. Like, is there still I guess I think there's still a place for application layer companies. But I'm curious, like, does everything just become model? Because the model is just so smart that it just does everything out of the box. I have an opinion on this, but I'm curious.
Yeah, I would love to know your opinion too. But yeah, like my read on this is that, um, yeah, certainly they want to go to the application layer to get more of the value that is being generated. No question about that. But at the end of the day, no matter how smart the model is, they don't know the context of your company. They don't know the metric that you care about. They are built to maximize the public benchmarks or some sort of other benchmark that has very little to do with your benchmarks and what you care about. So I don't think anytime soon we're going to see a complete sort of one-shot kind of transfer of a model to any use case within an enterprise application. I think the complexity is just too much, and the kind of nuances and differences between company to company is too big to allow these kind of one-shot use cases. I think at the end of the day, you need a level of post-training beyond what the model enables you to do, just out of the box. And then what we just talked about in terms of sort of economic, basically calculation, and also latency is another sort of dimension that also part of this calculation. But even on the quality side, I don't think we're going to see complete replacement of these kind of post-training by model providers anytime soon.
Yeah, I completely agree with you, by the way. I think the foundation model companies are moving into the application layer because the progress on the model side has stalled a little bit. And so as a result, to capture more economic value, actually the best way to do that is to move into the application layer. I think there will always be segments of either different verticals, specific companies that OpenAI is just not going to have the focus to be able to build for, I think, to your point. And those are really, really interesting. And I think to your point, it's like there are facts that you can learn from the internet, and then there's taste and there's values. So embedded within an organization, like something, for example, like, do I always give my customers refunds or do I never give them refunds? Like that's actually a value set judgment that's on a spectrum of like what you care about, how you prioritize different things. And then within an organization, there are like a million of those types of questions that are more value set philosophy based. I think those are never going to be like captured just by the base model, because it's very human and humanistic. It's very values oriented. Like I think the same thing also on even the data labeling side of the business, where like on the RLHF side, everyone's like, oh, well, like how long can we have these RLHF companies? Like eventually every single biologist will have spewed every single biological fact that we know today. And like that's kind of gone. And then similarly, like there were a ton of folks who were just coders and they were on Turing or Mercor. But eventually it's like we have all of the code that possibly could exist or something, enough to have a verified result. But I think the ultimate truth of that is like there's always these human taste types of things that are preference oriented, that there is no right answer. It's just how people feel about it. And I think those actually will always be there will always be a place for humans there, hopefully. Or I'm
Well,
just saying it just to make myself feel more comfortable that humans will continue to
I
have a
think
place.
I think at the end of the day, like building a business, we are mostly focused on B2B kind of companies, obviously, like, and businesses. For a business, for it to be unique, you have to have a set of different kind of values and set of different metrics. Otherwise, you have to distinguish yourself from, like, if you're like a bank, right? So how does a bank distinguish itself from another bank? If exactly the same services, the same set of metrics, the same set of values, then you don't have any distinguishing factor. If you do have a distinguishing factor, then you need a way of basically to teaching your agents, your AI agents, to learn those values and learn those benchmarks and sort of embody those kind of specific values. And that needs to happen through post-training. Now, you can argue that the model providers will also build those kind of tooling to create a custom version of their models for each client, which possible. Yes, they can do that too. That's a possibility. But yeah, like that's a much more meaningful argument than saying, oh, we're going to have one model for everyone and we're going to just basically use prompting to do everything. That, I don't think that word is that reasonable, and I don't think we're going to get there. But yeah, like maybe OpenAI, Anthropic, Google are going to start to build more tooling around customization. From my understanding, from what I've talked to OpenAI folks specifically, I don't think that's their focus today. Seems like a lot of focus is on consumer-facing type use cases, but eventually maybe they go there too.
I mean, I've been thinking about this more in the context of investing, but one thing that when I was young, I thought a lot about was like, why is it useful to have like 6 different, I don't know, ATS platforms, applicant tracking system platforms, and then every couple of years you get a new one. So like now you have Ashby and you have like, Ashby is replacing Greenhouse. And I was like, why is it useful to have so many of these? And I think the answer is that each one of them is kind of like an individual expression of that founder, that founding team, their values, and it trickles all the way down to how they prioritize their roadmap, their products, their customers, how they treat their employees. So it's actually like, it's almost like a philosophical expression of ATS in the world or whatever. As I think about like where we're moving to in the future, I think the cost of software development is going to zero or like trending to the cost of inference. And the cost of like building a business is going down. And so then do you actually have like way more expressions of something in the world? That's kind of interesting to me. And then like if you have 10 times as many businesses as people, then what you are voting for when you purchase something from one company versus another is that value set expression, to your point. So it's kind of interesting. I don't know where this ends up going, but like maybe there end up being brands, and it's like it's kind of like we that like represent some sort of value in some way. So like Costco might be a bulk purchases of things that are very value conscious but like high quality or something, and like organizations that actually stand for something. Apple might be like beautiful aesthetic and it just works. I don't really know, but those brand values become a little bit more valuable because they stand for something. I'm not really sure. I haven't really thought this entirely through, but I think it's an interesting area I've been thinking through.
Yeah, no, I think I hear you, and I think it's such a thoughtful way of basically approaching this. Basically, thinking about how you can include your values into the agents that you're gonna represent you in the future, or gonna do the job that you want to do inside. And I think for the most part, that's going to be the differentiator between different organizations. Otherwise, yeah, your bank is always gonna keep your money. That is the same, but then the interaction that you have with your bank is the important piece that's going to be different from one to another, and that's the reason that you choose one over another. And that sort of it should manifest itself into all these like agents that you're also building.
Yep, but that's why we need leaders who really care and give a shit.
That too. But I think on the other side, I think consumers are also going to have a lot of say in this and sort of pick, because they're going to have more options, hopefully, a lot more options in the future to pick between different solutions based on their values.
Yep, I hope so. Okay, last fun one for you, and then we can call it a day. Do you have a timeline for AGI?
Yeah, AGI timeline. I think we need a new architecture if we want to get to AGI, which means like it's a little bit, that's a kind of a unknown, and you don't know when you're going to get that kind of architecture. It's not something that we have today. It's not just this is scaling what we have. I don't think it's going to get there. Um, yeah, I would like, if you want to say like something like 5 to 10 years kind of thing, it's for me. I think we still need to do a lot of experimentation on architecture and then scale that up. But
And has that estimate gone up or gone
it's
down
gone up
since
for sure.
GPT-5? Okay.
Yeah, definitely in the last 6 months or so, it's gone up. Seems like we've exhausted RL in a lot of ways for frontier models, and then yeah, GPT-5 specifically wasn't such a big leap.
So what happened? You think the scaling laws just aren't working anymore? Because I thought the bitter lesson was like everyone who was bitter lesson pilled was just like we just throw more data, throw more compute, it'll work, and we'll see a linear improvement.
We, well, I think it was so we basically found test time compute as another sort of axis of uh, scaling. That didn't seem to go beyond a certain point. Like I won't see much difference between 30 seconds of thinking on GPT-5 and 5 minutes of thinking on GPT-5. Like seems like at some point it's going to saturate and starts actually creating a lot of um, it dilutes its own context in a way that confuses itself and starts like hallucinating more after a while. I think that's the problem that I don't think we actually. A lot of problems is not about thinking more. It's about knowing things and about having facts. And if the model doesn't have that fact, it's just not gonna figure it out by thinking more. I think that's the kind of which is like more about like now data. And so, okay, how do you get data? And data is not as scalable anymore because we exhausted all the available data. Now, how do you create new data and create new knowledge? I think that's the reason that I'm less bullish on the scaling in the same way that we used to have. Um, but I would say the other thing. I would say like I think this AGI thing and this like threshold of the day that you get to AGI is going to feel much less dramatic because by then we're going to have a ton of different ASIs in different domains. So at that point, I think by then your doctor is going to be probably a hybrid of AI and real doctor. Your architecture of house is going to be a combination of AI and real human. Um, your your chemist is going to be probably some sort of like what I'm trying to say is like you're going to have a ton of different superhuman AI in many parts of your life at that point that you already kind of are used to that kind of work. And at that point, like an AGI is not going to be such a dramatic shift anymore. So that's why I don't know like this thing, like this specific threshold of AGI is going to be that relevant because by that time, the world is a very different world where AI is going to be running a ton of different things anyway. It's just at that point, it's like more like formality of now, like we have another entity that's AGI. That's how
Yep.
I see it.
Yeah. So it'll be gradual, because sneak up on us, and we won't necessarily even notice.
Yeah. I
Yeah.
think in a couple of years, you're probably going to talk to an AI doctor more than an actual doctor. So
Yep.
that's a pretty big shift for the society.
Yeah.
Yeah.
Yeah. And it's almost like it is the change management. On the
Okay.
human side, that's probably going to be the harder thing.
Totally. Totally.
Got it. Cool. Are there any other AI tools you've been using that you've been really impressed with, or things that have really changed your life personally?
I mean, obviously, coding tools. We are that's my everyday, like mostly cloud code these days. Still some cursor, but mostly cloud code has been my go-to. I've enjoyed Claude specifically connecting it through MCP with multiple tools and multiple contexts. I use that heavily to prepare for meetings, to do research on different aspects that I need. That's like one of the best workflows that I see out there in terms of bringing context from everywhere and sort of chat and have that kind of dynamic conversation. I heavily use Claude for that specific reason. Um, Those are the main things. I wouldn't say there's a ton of. We have a lot of internal AI in the company, obviously, but not like personally. Like Nano Banana is actually been very fun. It's like a new kind of aspect. Um, I plan my garden with it. So I plan decorating a room with it. Sometimes, like it's actually quite handy in sort of day to day, more handy than I expected. A lot of times, like, okay, so I want to visualize something, I could just take it out and actually create like a visualization of that. It's actually quite good in that sense. I've been using it more these days.
Yeah, amazing. So Midi is now also an interior designer with the help of Nano Banana.
Exactly. Yeah. That's a great use case. That much.
So, well, that's all I had. I mean, thank you so much for joining. This was so much fun. And it's super, super exciting to hear everything that's going on in the RL gym world. I think it's a emerging category that is super interesting. And so always excited to talk to innovators who are working on things that are, I think, especially when you started Veris, very, very, very non-consensus, and like not a lot of people saw
Yeah.
what you saw. So thank you so much, Mehdi, and thanks again for being on the show.
Yeah. Thank you, Nina. Take care.